Hey everyone, Mr. Hauk here. As promised in the notes video, I want to go ahead and make a video going through my key to the 7.5 homework. The 7.5 homework is pretty long, and this is a very, very important set of notes for you to understand. So I figured I'd make this video where I walk you through each problem from the homework with my key, kind of explaining my thought process so that since I'm not there to actually answer your questions in person, hopefully this video kind of clarifies any questions you might have on the homework, okay? So obviously feel free to skip around. If you only have a question on number like 12 or something, then skip towards the end, look at number 12, kind of see how I talk through it, okay? But I'm going to go through all of them, and hopefully you guys find this helpful. All right, so number one, we're simplifying the trig expressions. If you remember from the notes, I mentioned when you're simplifying trig expressions, one of the best things you can do is convert everything into sines and cosines. So that's the approach that I took. Cosine is already in terms of cosine, so I left it. I just rewrote cosine as cosine over 1. Secant, which is cosine's reciprocal, is 1 over cosine. Now, because we're multiplying, cosine on top cancels with the cosine on the bottom. We have 1 divided by 1 left over, which equals 1. Second one, I did the same thing. Convert things into sines and cosines. So this is already a sine, we don't need to mess with it. I just wrote it as sine over 1. Cotangent, we know is cosine of x divided by sine of x. Sine of x is cancel. We have cosine of x divided by 1, which is just cosine of x. All right, number 2 requires the calculator. I just used Desmos, so you can use your TI-84 as well. So it's saying sine of theta is equal to 0.788. Cosine of theta is equal to 0.616. Find each of the following, round to the nearest thousandth. Rounding to the thousandth means you round to 3 decimal places. Okay? So, secant of theta, well, we know that secant of theta, again, we want to convert these to sines and cosines because we know information about sine and cosine. Secant is cosine's reciprocal, so secant of theta equals 1 divided by cosine of theta, and we know cosine of theta is 0.616. So 1 divided by 0.616, put that in a calculator, you get 1.623. Cotangent of theta is cosine of theta divided by sine of theta. It's one of our identities. We know cosine of theta and sine of theta. Plug in their values, divide them in the calculator, you get 0.782. Cosecant of theta can be rewritten as 1 over sine of theta, since cosecant and sine are reciprocals. We know what sine of theta is. 1 divided by sine of theta gives us 1.269. And then finally for this one, tangent of theta we can rewrite as sine over cosine, which is 0.788 over 0.616 in this example, which gives you 1.279. All right, so first page, pretty simple. It does ramp up in difficulty a little bit. All right. Number 3, find the exact value of each of the following to show that the Pythagorean identity holds true when theta equals 2 pi over 3. So this is going step by step. So first step, it says, okay, calculate sine of 2 pi over 3. This is just a unit circle knowledge. You have to have your unit circle memorized. Sine of 2 pi over 3, root 3 over 2. Now it's saying take that sine of 2 pi over 3, this root 3 over 2, and square it. So root 3 over 2 squared means root 3 over 2 times itself. Root 3 times root 3 is 3. 2 times 2 is 4. So root 3 over 2 squared gives us 3/4. Okay? Now calculate the cosine of 2 pi over 3. Again, that's from the unit circle. Cosine of 2 pi over 3 is negative 1/2. Then part D, take that cosine of 2 pi over 3 and square it. So negative 1/2 squared, negative 1/2 times negative 1/2, that's positive 1/4. And then now we want to take the sine of 2 pi over 3 squared that we found, the cosine of 2 pi over 3 squared that we found, and we want to add them together. Well, 3/4 plus 1/4, that equals 1. This verifies the Pythagorean identity, sine squared plus cosine squared equals 1, specifically for the angle theta equals 2 pi over 3. All right, number 4, simplify the trig expression to a single term. 1 minus sine squared. This is one of the Pythagorean identities rewritten. Okay, So 1 minus sine squared is the same thing as cosine squared. So replace this 1 minus sine squared with cosine squared. Now we have cosine squared divided by cotangent squared. Turn things into sines and cosines. Cosine squared is already a cosine. We leave it alone. Cotangent squared is cosine squared divided by sine squared, since cotangent is cosine divided by sine. Now I wanted to do keep, change, flip. I kept the top cosine squared. I wrote it as cosine squared over 1. Change the division to multiplication. Flip the bottom to be sine squared over cosine squared. Notice that cosine squareds cancel, leaving us with sine squared divided by 1, which is just sine squared. All right, number 5, a little bit more tricky here. Find all x-intercepts of the graph of f between 0 and 2 pi. So here's f. F is 10 cosine of 2x minus 5. Finding the x-intercepts means we're going to take this function and set it equal to 0. All right, so that's what I did. I took the function, I set it equal to 0. I added the 5 to the other side. Then I divided both sides by 10. And now we ask ourselves, where is cosine equal to a half? What angles on the unit circle is cosine equal to a half? Well, that's pi over 3 and 5 pi over 3. But I want to get some additional angles. I want to get the angles that are coterminal to these also. So coterminal to pi over 3, if I take pi over 3 and I add 2 pi, that would give me 7 pi over 3. If I take 5 pi over 3 and I add 2 pi, that would give me 11 pi over 3. Okay, the reason I'm doing this, notice that inside of the cosine, this is not an x, this is a 2x. So cosine is a half at these angles, but the angle here isn't x, it's 2x. So in order to get the x by itself, we take all these angles and we divide everything by 2. If you do pi over 3 divided by 2, you get pi over 6. 5 pi over 3 divided by 2, you get 5 pi over 6. 7 pi over 3 divided by 2, you get 7 pi over 6. 11 pi over 3 divided by 2, you get 11 pi over 6. And we stop there because if we continued, we'd be going past 2 pi. Okay, so here's our 4 different answers. All right, part B, let's look at a new function called g, and g is the old function f plus 3. Okay, we want to find all solutions where this new function is equal to 8. So take f, add 3, set it equal to 8. Negative 5 plus 3 is negative 2. Add the 2 to the other side. Divide both sides by 10. Now we have cosine of 2x equals positive 1. So now we ask ourselves, where is cosine positive 1? Cosine is positive 1 at 0, 2 pi, let's get some extra ones, 4 pi, 6 pi, so on and so forth, okay? But again, this is a 2x here. To get x by itself, we take all these angles where cosine is equal to 1, and we divide them by 2. 0 divided by 2 is still 0, 2 pi divided by 2 is pi, 4 pi divided by 2 is 2 pi, and we stop here because we don't want to go past 2 pi. All right, part C. Let's allow h of x to be this 1 plus tangent times secant divided by cosecant. Write an equivalent expression for h that uses only one trig function. So we are simplifying this down to a single trig function. Okay, so here's what we start with. I turned the tangent into sine over cosine. I turned the secant into 1 over cosine. I turned the cosecant into 1 over sine. So converting everything into sines and cosines. It's my best tip for when you're simplifying trig expressions. This piece right here, sine times 1 is sine. Cosine times itself is cosine squared. All right, here's what I did next. This part that has the fraction within a fraction, I did keep, change, flip. So I still have this 1 plus that just gets carried to the next step. Keep, change, flip. Sine over cosine squared, Division changes to multiplication. 1 over sine gets flipped to sine over 1. Sine times sine is sine squared. Cosine squared times 1 is cosine squared. And now notice, sine over cosine is tangent, so sine squared over cosine squared is tangent squared. And 1 plus tangent squared is one of our Pythagorean identities. 1 plus tangent squared is equal to secant squared. So the answer is secant squared of x. Okay, really good practice with simplifying trig expressions. Number 6, I thought it was weird that they put a calculator icon. You do not need a calculator for this problem. You can do this just fine. So it says, if tangent squared of theta equals 3, find secant of theta. Well, what do we know about tangent squared of theta? Well, here's one of our Pythagorean identities that you have to memorize. Notice if I take the 1 and I subtract it to the other side, I get that tangent squared of theta is secant squared of theta minus 1. So now, tangent squared of theta equals 3. Let's replace the tangent squared of theta with secant squared of theta minus 1. So now we have secant squared of theta minus 1 equals 3. Add the 1 to the other side. Now we have secant squared of theta equals 4. Take the square root of both sides. When we introduce the square root, don't forget your plus minus sign. Square root of secant squared is just secant. Plus minus square root of 4 is plus minus 2. All right, number 7. If tangent is less than cotangent and theta is between 0 and pi over 2, which of the following statements must be true? First off, these two are obviously wrong. Remember, the identities mean they are true for all angles, okay? So sine squared plus cosine squared will always equal 1. 1 plus secant squared is always going to equal was that plus secant squared? Let me look at that again. Yeah, well, either way, these two are definitely not going to equal each other, because if you subtract 1 from both sides, secant squared is not always going to equal cosecant squared, okay? So the question is, these two are definitely wrong. What about that one? That one turns out to be true. So when theta is between 0 and pi over 2, that's the first quadrant, okay? In the first quadrant, tangent is less than cotangent between 0 and pi over 4. You can look at a graph if you want to. That's what I would recommend, is going to Desmos and graphing both tangent and cotangent. You'll see that tangent is less than cotangent between 0 and pi over 4. Well, between 0 and pi over 4, the sine values are all smaller than the cosine values. So statement A is true. All right, number 8. If cotangent of theta equals 5/3 and theta is in quadrant 1, so that means we have all positive values, find sine, cosine, tangent, and cosecant of theta. Okay, so this is similar to one of the ones in the check your understanding from the notes. So if cotangent of theta is 5/3, okay, cotangent of theta is 5/3. Well, notice this relationship. Tangent of theta, think about SOHCAHTOA. Tangent is opposite over adjacent. Since cotangent is tangent's reciprocal, that means cotangent is adjacent over opposite. So we can build a triangle in the first quadrant where the adjacent will equal 5, the opposite side will be 3. So I did that. Here's the adjacent side being 5, here's the opposite side being 3. Then we can use Pythagorean's theorem rather, to find the hypotenuse. Go through the steps, you get that the hypotenuse is square root of 34. Now that we have the triangle fully built, you simply go and find the other trig expressions. Sine is opposite over hypotenuse, 3 over root 34. Cosine is adjacent over hypotenuse, 5 over root 34. Tangent is 3/5, opposite over adjacent. Cosecant is simply the reciprocal of sine. If sine is 3 over root 34, cosecant is root 34 over 3. Number 9, more simplifying trig expressions. Remember, convert things into sines and cosines. 1 over cosecant is the definition of sine, since sine and cosecant are reciprocals, so that one is very quick and easy. Part B, sine squared plus cosine squared is your one of your Pythagorean identities. The first one I told you to memorize. That's equal to 1. 1 over tangent is cotangent. C is one of those Pythagorean identities, that third one, rewritten. You just subtract. So here's what I ended up doing. So here's that Pythagorean identity. I subtracted the cosecant squared to the other side. So that makes the right side 0. And then I took the 1 and I subtracted it over to the right side. So now you have cotangent squared minus cosecant squared equals -1. Alright, part D. This is one of your Pythagorean identities rewritten. 1 minus sine squared is the same thing as cosine squared. 1 plus tangent squared is secant squared. So now the problem becomes cosine squared times secant squared. Turn things into sines and cosines. Cosine squared, I just rewrote it as cosine squared over 1. Secant squared is 1 over cosine squared. Notice the cosine squareds cancel. 1 divided by 1 is 1. Number 10. Little bit more involved one now. So same deal, we're simplifying. A lot of stuff happening. The secant squared minus 1 is one of your Pythagorean identities. That is tangent squared. So now we have tangent squared divided by secant squared. And then this 1 minus sine squared is also a Pythagorean identity. That's cosine squared. So now we have tangent squared over secant squared plus cosine squared. The tangent squared over secant squared, convert them to sines and cosines. Tangent squared is sine squared over cosine squared. Secant squared is 1 over cosine squared. You have this plus cosine squared that just carries on. Do keep, change, flip on this piece. Sine squared over cosine squared times cosine squared over 1. Cosine squareds cancel. Now you have sine squared divided by 1, which is sine squared, plus the cosine squared that carried. And then this is now another Pythagorean identity. Sine squared plus cosine squared equals 1. Alright. Number 11. Use the diagram. You just go back to the notes, by the way. The notes had, I think it was the 7.4 notes from the previous set. Showed you the different relationships. For example, they showed you that this right here represents cosecant. This right here represents secant. This is representing tangent. This is representing cotangent. So if you look at that 7.4 notes, you'll see that. So I just use that here. So what represents cosecant? That's the length from C to D. Segment CD. Find the value of theta. Okay, well notice that segment CD is 2 units long. So cosecant of theta is equal to 2, because this thing represents cosecant. So cosecant of theta equals 2. Sine and cosecant are reciprocals, so that means sine of theta is 1 over cosecant. So sine of theta is 1/2. If sine of theta is 1/2, and this is in quadrant 1, the theta has to be pi over 6. Okay. Now it says find AB. AB is represented as tangent. Again, look at that 7.4 notes. So if AB is tangent of theta, we already know theta is pi over 6. Then tangent of pi over 6 is root 3 over 3. That comes from, again, memorizing your unit circle values. All right, and then finally, a little bit complicated trig equation here. We have negative cotangent squared of mu. This is the Greek letter mu. Negative cotangent squared of mu plus 2 cosecant squared of mu equals 5. Okay, we want to solve for mu for angles between 0 and 2 pi. So what I did is I used this Pythagorean identity. 1 plus cotangent squared equals cosecant squared. I went ahead and subtracted the cosecant squared over here, and then the cotangent squared over here, and that gives me this. 1 minus cosecant squared is equal to negative cotangent squared. So I can replace this negative cotangent squared with 1 minus cosecant squared. All right, now we have a negative 1 cosecant squared and a positive 2 cosecant squared. These two, if you combine them because they're like terms, gives you a positive cosecant squared. And then I took this 1 and I subtracted it to the other side to give me 4. Take the square root of both sides. Cosecant of mu equals plus or minus square root of 4, which is plus or minus 2. If cosecant is plus or minus 2, then the reciprocal of cosecant is sine. So if cosecant is plus or minus 2, then sine is going to be plus or minus a half. And sine is positive or negative a half at these 4 angles. So our angle mu is pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right. Hopefully this video helps. If you needed help on any of these single homework problems, hopefully these explanations can help. I hope y'all have a